This is the Beyond the Hype, Edge Computing in Open Source. This is the developer stream, so I hope you are in the right, I hope you wanted to listen to me in this presentation, otherwise I might be lost, or, or you are. I am Manuel Will. I'm a network engineer. I work in the networking team in SUSE. It's not a super well-known team. Here's my colleague Madhu. And we are helping other products in SUSE with networking issues, and also looking at ahead and into what networking is bringing, like Edge, also SDN and NFV. And for example, there is in parallel another presentation about SDN, so you should check it. And the reason why I created this presentation is because I started looking at Edge like 4 months ago in my spare time. And I wish I had seen this presentation, because Edge isn't right now attracting a lot of media and bloggers and you can see a lot of videos, but most of them are repeating all the time the same things, and repeating use cases and challenges, but no one is really explaining where a developer can contribute and provide some effort. So I will try to do that. The first part of the presentation is I will repeat a bit these use cases and challenges to put everyone on the same page. There was a really cool presentation yesterday by Alan Clark about Edge that was covering that. And I have good news, because it will be repeated on Friday, so you should go there. I encourage you to go there. And yeah, the second part of the presentation, I will go into 4 different open source projects that are looking into Edge, just 1 centimeter deep, because we don't have a lot of time. But I hope it's enough to get you ongoing if you want to start contributing into Edge. And yeah, I think that's it. Let's start. So I'll try to cover the first part quickly, because probably you know about this. So edge computing is a distributed architecture that is mainly trying to process the data as close to the originating source as possible. And the reason for that is mainly 3. Well, it's 2, and 1 comes for free. Is to lower the cost of the data transport. I mean, we're generating a lot of data now. You know, all this, for example, IoT devices, which are getting smarter and smarter, they get generating even more data. We cannot just move everything to the data center. It's too expensive. So we prefer, or what's better is that we filter that data at the edge and then send what is important to the data center. Or we process everything already at the edge. There are new applications and business opportunities that all around. They need to very low latency, less than 20 milliseconds. And with the current architecture, it's impossible to get that. And then a third one that I would say comes for free is to increase locality. For example, in the EU, we had quite some controversy, because there are some companies operating in different countries, but they have a huge data center in one of the countries, which is storing information of users which are in different countries. And that created some legal issues. That will be maybe fixed with the locality that Edge is providing. So edge computing has been around for years. Why we're talking now about Edge? I think it's mainly because of the 5G network, 4.0, and also the growth of data. It's an unprecedented growth of data, and as I said, we can just move everything to the center. So the current centralized architectures cannot support these emerging applications and these business requirements. Yeah, this is Edge 101, very basic. This is a slide I stole from AT&T. AT&T is one of the biggest telco operators in the world. I think it's the biggest in the US. And it's like a 3 kilometers vision of a network architecture. And what we have is, well, the customer devices. Those devices connect to the internet either at home or in your company through the customer premises, or through access networks if you're using the mobile network. Those aggregate into the next node, which is here they call it telco real estate or network edge. I always knew it as the central office. And then central offices aggregate into the data centers. And normally the applications are running in the data centers. And you see here at the top is the latency that you will get in your device if you execute the application. Yeah, depending on where you execute the application. If you execute it the service here at the device, you get 2 milliseconds. If you are able to execute it at the customer premise or at the access network, you get less than 5 milliseconds. If your application is running at the central office, you get less than 20 milliseconds. And if you have it in the data center, you get more than 20 milliseconds, much more than 20 milliseconds. And if we want, for example, to do AR, VR, so augmented reality or virtual reality, less than 20 milliseconds, way less. So I don't have the time, but here there's a really cool video that shows how augmented reality doesn't work if you have more, I think, than 12 milliseconds. So the experience is ruined. So the requirement is clear. We need to be able to run the service either, here, or in the central offices. And this is going to be complicated because, for example, you can see here at the bottom. Right now, we are already having problems to connect tens of data centers, or there are companies that don't have so many data centers. Maybe they only have 2, and it's already quite a challenge to connect those and do things with both. So now we need to do it so we will have an architecture that connects thousands of nodes or even millions of nodes. And this is one of the first challenges that Edge will bring. By the way, Edge I would say, is a marathon, and we're not even in the first kilometer or first mile. So this is just a starting. And these are the challenges that I found, and I think they're most important. First of all, how to connect all these nodes together. This is my favorite because I'm a network engineer. And so I already said to connect all this, and also things like multi-tenancy, how you will handle that, how do you handle those 20 milliseconds with so many nodes. Then also the limited processing capacity and non-homogeneity. So right now in the data center, you have a lot of CPUs, you have a lot of storage, you have pipes, so you can get everything you want there. For example, we're running things like DPDK for data plane acceleration that is burning cores, but we can do that because we have a lot of cores. But to the node, the resources are limited there. So we need to be very careful and much more smarter to fix that. And also the non-homogeneity. So in the data centers right now, there's a lot of x86 architectures, but if we are moving more to the edge, we'll see ARM. And we might also see some more exotic architectures that we also need to manage. Another thing is the management of everything. Also the millions or thousands of nodes, how we can do that. The orchestration. Here what is important is that as I said, we have limited resources, so we cannot just move all the applications to the edge because it's too expensive. We cannot do that. And the operators are not going to spend so much money. So we might need to split our applications into, this is already ongoing, into microservices, and maybe put some microservices, the ones that are really important, that they run close to the user in the edge, and then the rest are running in the central data center or in the central offices. But we need some intelligence that is orchestrating all this. This is a challenge. And the maintainability, because right now, so for example, 2 weeks ago, one of our NICs in the data center broke, so I called a guy in the data center. He went there, he took the server, he replaced the NIC, he put it back, and that server rebooted, and that's it. But if your server is at the top of a mountain in an antenna, you cannot just call somebody to go there, climb, and do all that stuff. This is really expensive. This needs to be an exception that somebody needs to go there. So we need a lot of remote management, and things need to be really reliable so that this doesn't happen. Another challenge is the security, because we are opening up, or the telco providers, for example, will open up antennas or routers you have at home for third-party applications, and I think you can easily imagine that this will pose some problems. Security, they could open up for security holes and problems. To comply with this 20 milliseconds is already by itself a challenge, and the performance requirements that we need to provide is also a challenge. And the standardization, this is also some people forget about this one, but I think this is really cool. Edge is, so not only telco are interested in Edge, there are other industries that are interested in Edge, like retail or agriculture or utilities or automobiles. So these are coming from very different worlds, and I could bet you money that 80 or 85% of the problems they will see with Edge are the same. So I see a big chunk of ground where they can agree on a common solution, and then of course they can do things that are so that cover use cases for each of these industries. But most of the stuff I think is going to be common. So I think it's going to be a challenge that all these people that don't know each other sit down and agree on or collaborate on a common solution. This is where open source I think could help. I have a slide about that. And then quickly about use cases. You probably know about this. So IoT and industrial IoT, so providing monitoring a lot of stuff, for example, in agriculture. Video games. So I don't know if you play any of the esports, like Dota or Fortnite or League of Legends. So there is a lot of, if you can Google, there are people just changing the providers because they get 10 milliseconds less with of the one that I have right now, because it gives them an advantage. I mean, in these video games, you are competing with other people, and if they have a faster advantage, and they're just changing because of that. You can Google it. Autonomous vehicles. You know how the cars that will drive by themselves. Content delivery. So here I'm talking about all the Netflixes and all this new Apple thing, HBO. Yeah. We all want very good quality and very fast, and everything is running in the data center. It's not going to be easy. Yeah, video surveillance, NFV and C-run. Maybe you don't know about this one, but I'm familiar with that. This is virtualization. It's a technology that, so instead of running network functions or network services, you have in your network, you virtualize them or you containerize them. And this could be as easy as a firewall or as complicated as a EPC, an evolved packet core, that is a node running network. And Cloud Run is a bit in the same direction. And then a cool use case is the compute and floating. This morning, Thomas Di Giacomo showed it in the keynotes. And with xCloud and Stadia, I'm going also to that direction. These are platforms, first one by Microsoft and the second one I think is Google. There are like Spotify or Netflix, but for video games. So if you want to play to the latest video game, instead of having a computer with a big to be able to execute your game, the game is executed in the cloud. And then it's a streaming. And then you play from your computer, but the game is being executed in the cloud. And of course, if you shoot with your character, you want to automatically see or immediately see that it's shooting. If it takes 1 second or whatever it takes, some latency, the whole experience is killed. You will not like that. You can read about this one. They created a lot of edge nodes, so you cannot play everywhere, just in big cities. Yeah, so all this you can find in a lot of presentations, and yeah, but here is the developer forum, so we are tired of buzzwords. We want to understand how we can contribute to Edge, because this is cool. So I categorize a bit where you can contribute as a developer. Some of you might tell me, yeah, but what about this one? Okay, I just created it, and I think it matches the reality in 85% of the cases. So you have 3 areas where you can contribute as a developer in Edge. You have the Edge infrastructure. This is the software that will take care of provisioning the hardware and installing packages and putting then runtimes to run VMs or containers. So here, what I'm talking about is OpenStack, Kubernetes stuff. These 2 communities are targeting now Edge. Both, I think Kubernetes in a non-official way. There are projects looking into this, but they are not super. There is not an umbrella that is called Edge, where all these projects are. And Stack has that with the StarlingX that I will talk about in a few slides. Then we have the edge middleware, which is the layer that kind of abstracts the details of the hardware and provides some function for the edge application. So here are all the framework managers for the applications and edge libraries, and then the edge applications. And as I said, edge is just starting, and right now everything is very fragmented. There are a lot of projects, both in open and in the proprietary world. So I think there is a fight right now going on between open source and proprietary. And I think, well, what can I say, right? I think open source seems like the best approach because for both infrastructure and middleware. Because first of all, already, there are different worlds coming into Edge or interested into Edge, and they want a solution there. And they need, I think there is a lot of common ground where they can agree and collaborate. So this standardization could happen in open source. And of course, if all of us work in the same solutions, we will accelerate development and innovation, of course, and we will reduce fragmentation. I mean, I think it's normal that at the beginning of these technologies like Edge, there is a lot of fragmentation. At some point, there will be a consolidation, and yeah, I hope an open source project is the one that wins, or at least several open projects. Competition is always good. And also the locking is dangerous in Edge because you cannot just deploy Edge. If you deploy Edge, you also need a cloud that is in the data center. You also need this software that will do the orchestration and the management. And all these things, all these components need to talk to each other, need to integrate. If we do this, if a proprietary product wins, it will try to create the whole ecosystem, and it will be locked in because you probably be able to just replace one of the components with another one. So this is those are the dangers. So please, if you are developers, contribute to the open source projects that are targeting Edge. Okay, and with that, I will talk about 4 different open source communities and one. This is where you can contribute as a developer. The first one is ETSI. It's a standard body, so they create standards. And if you go on Friday to Alan Clark's presentation, he will show you, he has a slide with all the standards they agreed. Most of them are about APIs. But there is one, which is, I think, the most interesting for me, which is the architecture. Yeah, it's a bit ugly, sorry. But I put some colors to make it more understandable. Yeah, so this is the architecture for Edge that ETSI created. They call it the MEC, multi-access edge computing. And there you have the applications. So yeah, the applications we talked about before, any automotive stuff, IoT. By the way, this is running in the Edge host. The rest is running outside. The applications are running on top of the virtualization infrastructure, normally as VMs or containers. And this is where the hardware is and the operating systems and yeah, where you have the CPUs and your NICs and so on. It's really cool, I think, that they added this data plane. So there are a lot of components here that they are not saying, but to see, as a network engineer, to see that they are highlighting the data plane, this is really cool. So because in the end, the data plane is what will connect the different applications together and apply policies and all that good stuff, and also allow them to connect to the outside. So,
What's meant by multi-access?
I think it means multiple ways to access the edge, because I think what they, and I'm not exactly sure, but I think what they mean is that even if you can access edge through file and through customer premises, and there might be other ways, they want to do the same architecture for all of them. Yeah. There is also another, I didn't bring it with me, but there is another one that explains how this connects to the data centers with NFV and Mano. It's in the, I think if I can distribute the slides as they are right now, it's in the notes, all these links. Yeah. Then we have the mobile edge platform. I think this one falls into the middleware bucket, and this provides functions for the applications that they can consume. Things like server's registry. So I guess this will be some sort of inventory where all the traffic rule control. So they could kind of configure rules and policies, and that will be configured through the MP2 interface to the data plane. DNS handling, well, that stuff. Then we have the virtualization infrastructure manager, the VIM. You probably know that. Well, this is what manages the infrastructure. So here we have activities and all those, and those are the ones that, of course, will create the VMs and the containers, and will monitor that the infrastructure is okay. The mobile edge platform, which, as far as I read, this is what controls the lifecycle management of the applications, and also make sure that the correct functions are deployed in the mobile edge platforms that are deployed in each of the hosts. And this is just a very basic description, because we don't have a lot of time. And then the mobile edge orchestrator, that's one of the orchestrators that controls all the nodes, that knows about all of them. And for example, if you need to deploy a cool edge application that requires that some things are deployed in the data center and some things are deployed in the edge node, this is the one that has that intelligence to do that. And doing upgrades and yeah, that stuff. So why I show you this first is because what I want to do is, now that I will go into each of the open source communities that I think are the most interesting for Edge, I will try to fill these boxes so you know exactly what each of these communities is trying to address. Sorry.
Does this mobile edge host mean the edge compute node or different?
Yeah, this means an edge compute node, as far as I understood, this mobile edge host.
So you mean this node also has this virtualization capability?
Yeah, that's what they standardize.
Okay.
I mean, virtualization, or it could be also container based. Yeah.
I see. Normally the edge compute is just so embedded for.
But yeah, exactly. But we need now to deploy. So you cannot just guess one edge application in each node. That will be too monolithic. You need to share resources so that you can deploy several of them. We need a way to share. And let me check, how are we on time?
Storage appear in this picture?
Storage. Ooh. I guess storage should be here, I guess.
Local storage.
Data plane, that's part of the storage. Local data plane, okay.
That's one of the things these guys investigating about storage, because should it be centralized and sharing some sort of, I don't know, some NFS or something like that, or will it be a Ceph?
Centrally the manager there, right at the same time. So, yeah.
But let me go into the first open source community that is targeting Edge, StarlingX. Probably you know about them. So StarlingX is a cloud infrastructure software optimized for Edge. It's based on OpenStack, and it promises enhanced OpenStack with some extras in. These are some of the challenges that I told you before. So scalability, small footprint, ultra low latency, this means 20 seconds, edge security, and high reliability. And then if you go to their website, they show different use cases, like multi-access edge computing. Well, I think by this they mean that they are compatible with the ETSI architecture, because they're using exactly the same name. And here they talk about augmented and virtual reality, enterprise focus, small cells for servers and stadiums. I mean, this is a lot of marketing, because right now they are not there yet. They also talk about high bandwidth and large volume applications. Here, what they mean is content delivery, surveillance. They also talk about healthcare. I think what they mean is that a doctor could diagnose a patient even if he's remote, which is really cool. And also low latency 5G and industrial IoT. This is autonomous vehicles, industrial automation, so all what you can hear in this industry 4.0. And a bit of the history in the community of StarlingX. StarlingX was open source in 2018. It's under the OpenStack Foundation, and it's mainly driven by Intel and Wind River. And the reason for this is that StarlingX was a proprietary product that was targeting telco operators, and they open sourced it. The first release comes next month in May, and I think there's a quite active community. So the mailing list has a lot of mails. They are very friendly. I talked to several of them. They're really nice people. There are patches every day coming in, but the documentation is really poor. They need to improve this. Especially in some projects, it's really hard to understand what those projects are doing or how to install them, because there is nothing, absolutely nothing. You need to look at the code. And also, the diversity is not that good. It's mainly people from Intel and Wind River. They are changing both of this. So, for example, for the documentation, 3 weeks ago, they approved a spec that is basically saying, guys, you need all the projects, we need to do this and that, because the documentation needs to improve. And for the diversity, I think they're also improving this. For example, the TSC that they have has people in different companies.
It's both Intel. Intel bought one stream, right?
Did they? I don't know. Okay. Yeah, but then it's an Intel. I didn't know that. Okay. And yeah, this is the architecture, or the architecture, as Alan was saying. They also added a Kubernetes part. And yeah, there's a lot of words here, but what you need to understand here is that it's mainly two things. They have open source projects like OpenStack, OVS, and so on, but they are not really open sourced. Remember that this is coming from a proprietary product, and what they were doing was downloading OpenStack, upstream OpenStack, and then adding some patches that were targeting telco stuff like data plane acceleration and monitoring and increased HA, and then they were selling that, supporting those extra features that they were adding. So it's some sort of fork. When they open sourced this, of course, didn't allow that, or I don't know how they agreed, but in the last month, they've been working on closing those gaps. And their target was to close all of them before May, so before next month, but I don't think they're ready. They still have some patches that they need to contribute. Problem is, of course, that if you fork, some of the things are already in the project. How you handle all these two projects that are doing the same, or these two patches. But that's the effort they're mainly doing in the last month. And that's one part. And the second part is this new StarlingX services. And in the long term, when they manage to close all those gaps, this is what StarlingX will be about. All these services that, here you see 5 of them. There are some extra, like distributed cloud and NFV cloud. And all these projects were programmed with the edge in mind, with a very distributed architecture in mind. And you might, of course, ask, if you are familiar with OpenStack, you might tell me, okay, fault management. We have already several projects that are doing fault management or host management. And yes, it's true. They didn't reuse anything. They did everything from scratch, as far as I know, because again, documentation is not good, especially in these projects. And the only difference that I would say is what I just said, that these were developed from the beginning thinking of edge. So but I think there will be competition, and then in the end, one of them will win. But so far, there are other projects that are doing more or less the same, I would say.
So how much is this one different from, the edge solution will be different from the one in traditional data center we are using now, or using
One?
on stack?
So how it differs from normal OpenStack?
If we take an example of Ironic that does manage the whole compute in the data center, how we would be using a trim version of the Ironic, or it's going to be a brand new?
They are using a brand new thing here in host management. There is not even, it's not, for example, we're using in our OpenStack, we use Cobbler. Some other projects are using, as you say, Ironic. They build something new, a new one. I would love to tell you more, but the documentation is so bad that it's really hard to understand. But what they told me is that they built it from scratch, and they didn't rely on all the tools. So I don't know. There will be competition, I guess.
I'm just more curious to know exactly when you say it will be, they're going to building it from the scratch. So when they are building from the scratch, what does it mean that they want to push the newer OS or OpenStack OS that purposely built for the edge on a remote machine or a server that is far away from?
So let me go to the next slide. Maybe shows you a bit more details. This is one slide that, so what they try to do, they want to deploy OpenStack on all the nodes, even in the ones that don't have a lot of resources. And how they will then achieve a low footprint is because some of the services will be running in the central place and will not be deployed in the small deployments. So for example, Horizon and Glance and Keystone, that's apparently something that they already have running. Those will be running in the central place, and they have something called a proxy, distributed cloud proxy. That through that, these guys here are able to consume the services by the central Keystone, central Glance, and central Horizon. I think this proxy, for example, for Glance is doing some sort of caching, so that they're not storing everything in their sender backends, but it's here, and they only store this kind of cache images that they need. This is the only slide I found about distribute. They don't explain much more, so it's hard. But
I assume there's going to be a lot of latency issues in one of the previous slides that you showed for the infrastructure management. So like the hardware management, when we get an update or if we get an issue, that a compute or a storage that is far away from the same place, going to bring in, diagnose the issue, fix it, replace it, or assume pushing a new OS update or any firmware update or hardware.
yeah,
Or replace a component. So it's not going to be an easy way because you don't have people direct access to the hardware there.
right,
So you need to push those images over the wire for protocol that will be.
exactly. You need to manage everything remotely. It's impossible that you go there. Yeah, it's a challenge. I don't know how they are going to solve it, but that's
The development will be okay, but for management it's going to be really challenging.
that's what these projects are targeting, and the config management. We need to see. I'm really looking forward for the first release in a month to understand all this, because up until now they've been focusing mainly on closing the gaps, because that's something I think they even signed with the OpenStack Foundation. Yeah. Yeah, that's mainly what I wanted to tell you. Then how you can deploy and contribute. To deploy, I would say wait a month until they release. You can deploy on bare metal or a virtual environment, QEMU or VirtualBox. All-in-one is available, and here is a link where you can check. And to contribute, well, StarlingX projects are using the same OpenStack tool, so it's easy if you have contributed to OpenStack. So Garrett, Sul. And 3 types of contribution are welcome. You can help StarlingX close those forked gaps, although probably you shouldn't do this because they know better than a person that just joined what are the gaps. You can help develop the STX projects further, or you can help with the packaging process, which is a bit messy, I would say. Because right now you cannot install just one of the projects, not just because there's no documentation, but because they build everything in ISOs. And yeah, you can just install the ISO. And also they have some multi-OS issues. So right now it only works, I think, in Ubuntu, and the packaging stuff works only in one operating system, which I don't know, I forgot now. But yeah. So one thing that we could do is, of course, provide OpenSUSE support. Yeah, and how it maps to this. Of course, the virtualization infrastructure, and they have the OpenStack. I put star there because it's not upstream OpenStack yet. And that's it. Yeah, and the distributed cloud manager, I think it's a bit here in the orchestration, but that's it. The rest they don't touch. Okay, it's Akraino. Akraino, this is different from StarlingX because StarlingX provides you a solution for Edge, whereas Akraino, it has like sub-projects. They call them blueprints. And each blueprint is trying to implement one use case with open source projects. So they do two things. They go around, okay, they think about a use case, and they go around and try to find open source communities that will allow them to implement that use case. They integrate them together, and then if they find problems, which they will find, features which are missing or integration issues, they go to these open source communities and try to fix them or at least report them. So this is like a call of action to open source to implement Edge use cases. They are targeting two families, network Edge use cases and enterprise and industrial IoT use cases. And this was launched in 2018. The first release is coming also in a month, and then they will release every 6 months. I've been told that in the first release will be not very good, so we should wait maybe until the second release. So for example, they are using StarlingX as an infrastructure deployer. Several companies are involved, especially AT&T, and they are not very active but slowly improving. So they really started in January this year. So if you want to contribute here, you need to know that the current activity is focused on investigating, discussing use cases, but the code, you will not find much, not yet. And yeah, this intends to cover both infrastructure and middleware part. And so far, they have 10 use cases approved. And the thing that is a bit weird, and they did this on purpose, is that these 10 blueprints, they have nothing in common. Some of them are using the same deployer, which is Airship, but the rest, they have absolutely nothing in common. They're using even different components to build these use cases. And they don't want to be that independent. At some point, they want to be, they call it loosely coupled. For example, with a CI/CD that will test each of these use cases, make sure that it works before. And then if it works, then they will be released. And this is under the Linux Foundation Edge, which is a new section that Linux Foundation created. This is the architecture, which has a lot of boxes, but most of or a lot of the boxes are purple, and purple just means future release, to be disclosed. So it's not much that we can learn about them. So here they talk a lot about Airship, although there are other ways to deploy, OpenStack or Kubernetes. And yeah, most of the stuff, as I said, still we need to see. So there are several cases, those blueprints that are working, and those are based on Airship and ONAP as the orchestrator. And yeah, but the rest is work ongoing. So how to deploy and contribute? To deploy, there is not a standard way, as I said. So you need to go to the wiki of each of these blueprints and then learn how they deploy it. The wikis, I checked them, and most of them are not yet ready for you to deploy. So wait a bit. Perhaps in the future, Airship is the way to do it. I don't know. Yeah, and here are the approved blueprints that you can check. And if you want to contribute, they are looking for contributors. They have two types of projects. Some projects are focusing on infrastructure. There's 3. And some projects are focusing on middleware. This Elliot, Seba, Edge Video. Yeah, very nice people there, but still a lot of work ahead. And if we go to the MEC architecture, what they have is the virtualization infrastructure. This depends a lot on the project. The Vim as well. Some are OpenStack, some are Kubernetes, some are using Airship. And then they have one application which is open source for you to test it. They are using, the ones that I read, they're using ONAP there. And then the Mobile Edge Platform and the Mobile Edge Platform Manager, they want to address this, but so far is to be disclosed. Of course, it will depend at the end of the blueprints, but I don't know any of them right now which are really working. Yeah. How are we doing on time? Okay. 2 are left, but the last one is very quickly. Then OPNFV. This is a community where I am working. I'm part of the TSC. And open platform, OPNFV is open platform for NFV. And this is similar to Akraino, but in this way, what we're trying to build is a platform. So connect different open source projects that are working on infrastructure and make sure they work, and they create this platform and then run tests against that platform. And if we find issues and problems, then we go to the open source community and try to fix them or report the bugs that we found. And the objectives are to build a carrier-grade integrated platform, to bring top NFV companies together in open source ground, so neutral ground, so that we accelerate innovation. And then also collaborate with ETSI NFV. ETSI also created an architecture for NFV, and they had a testing group, and we're collaborating with them. The history is that, well, OPNFV is already pretty old community, started in September 2014. And the OPNFV Edge group was founded in May 2018, around that. And the idea, in this case, of OPNFV, how it wants to position itself is we want to create a list of test cases and implement them and run them against any of the open source edge infrastructure, in this case, communities that are around. So we want to be neutral, so we don't care. We want to test if it's Airship that is doing some edge stuff, then we want to test it, or we want to run the same test in StarlingX, and then at some point say, okay, so far this is better than the other, but just neutral. And of course going to the communities and helping them to solve these problems. And the cool thing that we have is that we have a unique hardware distribution, because several companies contributed with hardware. We have hardware in China, in different places. We have hardware in Sweden, in Finland, in the US. And that allows us to create architectures that are similar to Edge, because the latency between those will be high. And this is led by 2 colleagues of China Mobile, and there's a few people participating, like me. And we define a list of test cases, and we are being inspired, let's say, by OpenStack Edge group. There is a quite active group in OpenStack that is discussing around Edge, and not only focusing on StarlingX, but also discussing, for example, with Keystone about Keystone Federation, or with Glance to talk about Glance caching. And we are talking a lot with them. And some of the test cases we were inspired, let's say, by the OpenStack Edge group. Yeah, in this case, I don't have an architecture because we are just talking about testing. These are some of the examples that we created. So, for example, to address the resource limitation problems that we will have at Edge, we have a test about resource isolation. We don't want that one application monopolizes all the resources. Yeah, we have another test to check that the controller and the compute can run in one node, because in case you don't have a lot of resources, that's the best approach. Also, how from a central place we can collect the information and the resources of the different nodes. Then some other in the management area. Doing remote upgrades from the center to the nodes, centralized alarm and warning, provisioning new edge hardware tests, even if they are far away. Let's see how that works. Single sign-on, Keystone stuff. So if we want to, from using the same user and password, be able to create resources in the different nodes, and also some about reliability. I think this is really cool, because if we increase the latency and the jitter, how will things work? How will, I think the gentleman that was there, the management stuff, if the latency is really high, how everything will work. Maybe things break apart at some point. Something but we want to learn where it breaks and then go to these communities and try to fix it with them. And also to back up information. Maybe the nodes could back up information back to the central place. There are more, but yeah, deployment, well, we don't deploy anything. So what we expect is that the person deploys, for example, StarlingX, and then we have all these tests. We want to implement all these tests in a Docker container, and then we will just spin up the Docker and then test everything, test that platform. So if you want to contribute, we have this list where all the test cases are. We have bi-weekly meetings on Wednesdays at 1 UTC. And we also are starting to discuss about how we implement this. And we have an OPNFV for testing, so we will reuse them. So if you want to contribute, you are welcome. Yeah, and the last thing, it's Linux Foundation Edge. This is a section that started, it was announced on January 24th, so very recently. It contains 5 projects, so Edge, Akraino-Edge, which started before, but this was under another section, and then they moved here into the Linux Edge. And yeah, just very quickly about those. So Edge, I didn't spend much time with this, but yeah, EdgeX Foundry project. I think this one fits more into the middleware. They call it loosely coupled microservices framework, allowing to plug and play things. Yeah. So you have more information there. Then another project is the Home Edge project, which this was created by Samsung, but the code is still not there. They promised code, but they haven't provided yet. And this also is, I think, falls into the bucket of the middleware. So it's a framework to run devices. Then the open glossary of edge computing. I think this is a cool one because this is like a dictionary of edge. So if you don't know about edge, anything about edge, you should start with this one. You have a GitHub page where they are just defining all the different concepts and words that you need to start learning, to start understanding edge. They call it the glossary. And of course, if you want to change something, you need to go through reviews and everything, so everyone agrees. So you can there find what is edge computing, what is 5G. Yeah. And it also provides a report about the state of the art of edge. This is something I, of course, read before doing this presentation. And I don't know how often they are refreshing and updating this one. Yeah, and the last one is this project EVE, contributed by Sededa, but still no code, so I cannot really comment anything. Coming soon. They promised that this will be available in March, but last week was not there, so I don't know.
Did they say that? Did they say that?
Yeah, they said this year. Next month. Maybe legal issues, I don't know. But I'm sure before summer you will be there. Yeah, and that's all I wanted to show you. I also want to recommend you that tomorrow's Thursday. So Friday, you go to this presentation. What is your edge from the cloud to the edge, extending your reach? And this is, I didn't put the name. This is given by Alan Clark, a guy who is in the board of the Linux Foundation and the OpenStack Foundation. So he knows a lot about OpenStack. So he will explain you all the different use cases that they are talking about, and that at that level. Yeah. So I really recommend it. Yeah, and if you have questions, I think we have time.
I just have a quick question. You mentioned the middleware a couple times. Where is this layer running?
Yeah.
Edge compute or
Yeah. So parts of it is in the edge compute, and parts of it.
okay, both sides.
Yeah.
Okay.
So parts. So I consider middleware as this one, which will be running in the edge cloud, so directly providing APIs and functions to the edge application, and then this one, which is managing the different edge platforms, and also can talk to the Vim, to OpenStack or Kubernetes. So it can take care of the life management of the applications. For example, application is broken, we need to deploy again, or we need to upgrade the application, or yeah, things like that. So I consider this size, but this is an area which is really starting right now. I haven't seen any open source project looking into this. Whereas I heard rumors that there are proprietary products already in these areas. So this is a fight that we are losing. Yes.
You mentioned in here some of the projects loosely coupled microservices, which usually implies like REST interfaces and that
This
kind of
one.
interaction. How does that fit with the low latency model? Like using TCP and HTTP
Yeah, that's a good
XML
question.
and whatever else doesn't say low latency to me.
Yeah, yeah.
Is there do they have like parsimonious protocols that you would use instead of the standard REST interfaces?
I don't know. I don't really know. So I know by Alan Clark's presentation that under Eclipse, there are a lot of different small open source projects that are trying new protocols that are being standardized for that reason. And yeah, so, but there is a lot of fragmentation right now. If you go to the presentation, you will see that there are like 30 different projects. And in ITF and all these standard bodies, they are already having discussions about these new protocols, which probably are needed to reach those latencies, and they're testing them. But I don't think these projects are doing this right now.
They call the next generation protocols. ETSI is also
Okay.
standards about specifically meant for our 5G.
For 5G, okay. And they are discussing new protocols.
Yeah.
Okay. Yeah. So, but this is just starting, really. So this is an area where, yeah.
Nothing is published yet.
Nothing's published? Okay, yeah, most of the stuff is in the drafts, like at 5G, so yeah. I think this will take years. Maybe a good place to invest now time if you want to keep your job. Yeah, I think I will share the slides, right? Probably, so I'll distribute it, and hopefully in the next SUSECON I can also show a demo of this is working, so. Yeah, any more questions? Okay, so yeah, thank you for attending, guys.